Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at metals and non-metals, and hopefully by the end of this lesson we're going to be able to describe the different properties of those metals and non-metals. To start us off though, a couple of questions based around our previous lesson, so I'm going to give you about 3 minutes to have a go at these. Okay, let's check those answers then. So to calculate the RF value, what we need to do is the distance travelled by the substance divided by the distance travelled by the solvent. So give yourself a tick if you got that right. In terms of how we carry out paper chromatography then, first mark is for saying we draw a pencil line a couple of centimetres up from the bottom of the filter paper. Second mark is for saying we place a spot from each pen on the line. Third mark is if you said we're going to use a paintbrush to lift a sample of ink from the note and place it on the line. Fourth mark is for saying we place the filter paper in a beaker with water. Fifth one is for saying we leave the paper in the water so the solvent runs up it. And the final mark there is for matching the pattern from the pen with the note. So that means we're going to match up those blobs that form, and that allows us to identify which pen wrote the note. So add up your scores. This is a total of 7 today, so give yourself a mark out of 7. The first thing we need to know then is what we mean by this phrase physical property. So whenever we see that phrase physical property, then it's a characteristic that we can observe or measure. So don't mix this up with other types of properties. Physical properties are characteristics that we can either observe or measure. So what I want you to do is think about metals and non-metals, and I want you to see if you can make a list of physical properties of metals and non-metals. And then, if you've still got a bit of time left before we move on, see if you can suggest how we would measure those properties. So I'm going to give you about another couple of minutes to have a go at this. Make sure you've all written down the definition of physical property though before you move on to your lists. So what we've got on that left-hand side of the table are all of the different physical properties that you need to consider when it comes to metals and non-metals. So we've got their appearance, so what they look like, are they shiny, are they dull, so forth. Their melting point and boiling point. Their state at room temperature, so solid, liquid or gas. Whether they're malleable or brittle when they're solid. And I've given you the definitions for those in the bottom left. So malleable means that we can bend it without it shattering, and a brittle substance will shatter when we hammer it. Ductile or non-ductile when solid, and the definition for those is in the bottom right there. So you can see ductile means we can pull it into wires. Non-ductile, when we pull it, it just snaps. And then their thermal conductivity and their electrical conductivity. So what I would like you to do then is copy that table into your books. Make sure you get the definitions for malleable, brittle, ductile and non-ductile written down as well as reminders, because those are key terms you need to know. And then what I want you to have a go at doing is filling out what those physical properties would be for metals first of all, and then for the non-metals. So I'm going to give you about 5 minutes to get that done. Okay, let's double check to make sure we've got all of those properties right for metals and non-metals. Obviously tick any you've got right, and if you haven't got them or you've got them wrong, make sure you do correct these. So let's do metals first of all. When we consider the appearance of metals, they are shiny on the most part. When we think about their melting and boiling points, these are usually high. They are usually a solid state at room temperature. When they're solid, they are malleable, so we can bend them. They're ductile when they're solid, so we can stretch them into wires. And they're good conductors of both heat and electricity. If we consider the non-metals then, they generally have a dull appearance. They usually have low melting and boiling points. They've got a sort of state of room temperature which may be solid, but it may be gas. It's about half and half when we look at the number of elements there. When they're solid, they're brittle, and they're non-ductile when solid. And then finally, they're poor conductors of both heat and electricity. So I'll leave this up for another minute in case you need it, but if you need longer to write those in, obviously you can just hit pause on the video. The second type of property we need to know about are the chemical properties. So again, make sure you've got this definition written in your book. When we're talking about the chemical properties of a substance, this is a characteristic that we can only determine by studying its chemical reactions. So this isn't something you just look at the object and you know what the properties are. These are the ones that we've got to do a chemical reaction in order to actually study them. So I'll leave this up for another minute so you can get that definition written down. Next thing I'd like you to have a go at doing then are looking at a couple of these chemical properties, just recapping on when we form ions for metals and non-metals. So 4 blanks, have a go at writing down those 2 sentences and filling in the blanks. Let's just double check to make sure we remembered these right. So metals lose electrons to form positive ions, whereas non-metals gain electrons to form negative ions. So give yourself a tick for each one of those you got right. If you didn't get it right, obviously make sure you get the correction in there. And then give yourself a mark out of 4. One of the key reactions that we find is when both metals and non-metals react with oxygen. And when they do so, they form a particular kind of compound. So see if you can fill in the blank there. Then what we find is if we take that compound that we formed and dissolve it in water, then we get 2 different types of solution. So the metal oxides are going to produce alkaline solutions, but the non-metal oxides will produce acidic solutions. So that's one of those key chemical properties that we find, is that metal oxides when dissolved in water produce an alkaline solution, whereas non-metal oxides dissolved in water produce acidic solutions. So make sure you've got those sentences written in your book. I'll leave these up for a couple more minutes for you. Hopefully we've all worked out the missing word is the word oxides. I did kind of give it away with the next part. So make sure your missing word is the word oxides. The next thing we need to know is where we find these things on the periodic table. Now this is something you don't have to memorise, which is good news because it's quite a lot to try to sink in. But you are going to get one in your exam and you need to be able to find things quick. Now, the first rule, hopefully, we all remember about the periodic table is it's only elements. So don't be that muppet that sits there spending goodness knows how long of your exam looking for something as a compound on the periodic table. It's not going to be there because it's not an element. So only elements are on the periodic table. And you are going to get much quicker at finding them if you know where metals are found, where non-metals are found, and how those elements are arranged. So what I'd like you to do is 3 questions on the screen, answer those 3 questions in your book, and then make sure you write down the sentence at the bottom there about the boundary. When it comes to where we're going to find the metals then, they are on the left hand side, and actually metals make up the vast majority of the periodic table when you look at it. Now, the ones that you may have been given in class will have a little zigzag line, so a little step down line towards the right, and that's our boundary between the metals and the non-metals. Everything to the left of that is a metal. So aluminium, germanium, and so on, this is our metal edge, if you like. To the right of that, then we've got the non-metals. And you'll notice that actually if you look at the periodic table, there's actually a small number of them that are non-metals. The vast majority are metals. Then in terms of how we've arranged them on the periodic table, then they're arranged in periods and groups. So the periods are the horizontal rows going from left to right, and the groups are the vertical columns going from top to bottom. So we've put these elements into specific locations based on the periods and the groups, and that all ties in to their atomic number. Because if you have a look, you start off with hydrogen as the atomic number 1 in the top left, then you go across and you find helium is number 2, back to the left and we've got lithium for 3, beryllium is 4, boron is 5, and so on. So it's increasing atomic number, but we've then divided those up into the groups and the periods. Now, where we've got that little step zigzag line that goes between things like the aluminium, the silicon, the germanium, the arsenic, and so forth, then that is that boundary area between the metals and the non-metals. And what we find is that these elements that we find along that boundary can actually have properties of both metals and non-metals. And silicon is probably the best example that you're likely to have heard of about this. So silicon is a non-metal, but it actually is really useful in things like computer chips and so on, because it can conduct electricity quite well. So what we've got there is a non-metal that is actually a good conductor. So it's got a property of a metal even though it's a non-metal. So just remember that boundary area can have properties of both metals and non-metals there. Okay, next up we've got 3 more questions to have a go at answering. Which 2 elements are found as liquids, where are the gases found, and what do the numbers represent at the side and top of the periodic table? So a couple of minutes to answer those. Okay, let's check those answers then. So first one, which 2 elements are liquids? The answer is bromine and mercury. It's a really good one to know for any future quizzes you may be involved with. In terms of where we find the gases, these are on the far right hand side of the periodic table mainly. So your gases are all of the noble gases, the furthest column on that right hand side, and then we've got another 5 at different parts. So we've also got nitrogen, oxygen, fluorine and chlorine, but on the very far left hand side we've got hydrogen as well. So in terms of our gases, we've got hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon and radon. That's it. Everything else on the periodic table, with the exception of bromine and our mercury of course, are solids. Then what we find is the numbers that are running down the left hand side of the periodic table, those are the period numbers, and the numbers across the top, those are the group numbers. And on some periodic tables you find that you've got 2 sets of numbers at the top. So you'll actually have one that literally goes 1, 2, and then we'll jump to 3, 4, 5, 6, 7 and 8 or 0. And the other ones will actually count up 1, 2, 3, 4 all the way to 18. Now what you've actually got there are the older system, which is the one that only goes up to the 8 or the 0, and then the newer IUPAC system, which goes up to 18. So just know that those are group numbers. Last thing for today then is the plenary question. So those of you with a target grade up to grade 5, it's the 2 columns on the left. Those of you with a target grade over grade 5, it's the 2 columns on the right. So I'll leave these up for about 3 minutes today, but as always, if you need longer, just hit pause and take as long as you need.